Welcome back, guys. Mr. G here. As promised, we are now going to talk about the average gradient. Okay, now basically, I said in the introductory video that calculus helps us to understand change, why things change the way they do, okay, or why does one variable seem to affect another the way it does, okay. So when we look at, or when you think of the average gradient, actually, you can think of it as the average rate of change, okay. So if they say find the average gradient of a function, they're actually saying find the average rate of change. But now this has to be defined in a specific interval. You've got to be given an interval in which you can work with. So if you see, I've got 2 points here that I have plotted, A and B, all right? And point A, you can see it has an X value here of, according to this coordinate here, this thing here. Well, my line is not that straight, is -3, and according to this here, this is -1. Maybe if I try zoom in nicely, they will all come through. Yes, I think that's a better one. And so let me just get rid of these lines here, and then we can have a nice clear drawing. You can see through the grid actually now that we've got values that make sense. So there's a value and there is a value. Okay, so whenever you have to find the average gradient, you are actually going to have an interval that you're working with. And obviously, this interval will include X values. Okay, so in this case, if we were to find the average gradient of the function f, and we know we're still dealing with that same function in the introduction, x squared minus 5. In the interval, now this will be usually a closed interval, sometimes it can be open, but here we're having a closed interval, AB, okay, AB, and as I said, this is actually x, okay? These are values of x. So in this case, we can see that we looking at points A and B, we are looking at the interval -3 and 1, okay, to 1, all right? So if we were to find the average gradient of f between -3 and -1, actually that's a -1, we are basically looking at the gradient of the line that is joining, okay, the points A and B in this case. So I hope that is clear. The average gradient is basically the gradient of a line between the two given points. So what may happen is they may give you a function, f of x is equal to x cubed plus 1, for example. And they say find the average gradient of this in the interval 1 and 4. Then you know that the average gradient, you've got to actually find the gradient between what? The points. So for you to find the actual coordinates of the points, you got to substitute f of 1 and you got to substitute f of 4. Now, from grade 10, we started to discuss the formula for a gradient. We did the same thing in grade 11. So if you're wondering, how are we going to find this gradient? It's simple. We're just going to use the gradient formula. Then it will have us actually find what? The average gradient. So quickly, in essence, if I'm going to find the average gradient, I'm actually finding, as I said, the gradient AB. That's it. And in finding the gradient AB, guys, I just want to do something here. Okay, quickly. Okay, yes. So in finding the gradient AB, guys, what is happening is, you know, it was always changing y over changing x, right? So in this case, you are saying, well, it is the x, the y values are given. So you might as well go for this and say, well, y at A is 4 minus y at B, which is -4. And then x at A is -3. And then minus x at B -1. So this is going to be 8 and you can see there's going to be a plus here, and so we're going to have a -2, and it makes sense that the gradient is negative because we can see this is a straight line with a negative slope. So that is basically the simple interpretation of the average gradient. Now, I want to point out the fact that these guys can actually change from case to case. At one point, you can have a situation like that and you have to find the average gradient, or you can have a situation like that and have to find the average gradient. You can also have a situation in this case like this, and you still have to find the average gradient, or this point can go up and you still have to find the average gradient. Whatever the situation is, the picture here that I'm giving you is that average gradient is not that it is a thing of stereotype. No, you can actually have different cases or different scenarios where you need to find that thing, this average gradient. So it just differs from point to point. As you can see, I'm moving my points here, and this is just tracing how I move this point. Don't worry about that. So that is basically the principle. You can go ahead and try, maybe let me give you a problem, a courtesy one really here, and say, well, try this. Maybe let me just clear up everything so that you're not confused. Try. What are you finding here? Given g of x is equal to x cubed, okay, in the interval 0 and 3, you just got to find average gradient. And you know by now the definition, it is just the gradient of a line between those 2 points. So go for it. I'll catch you later in the next video, where now we are going to come up with something very, very interesting. That is finding now a general formula for the average gradient. I hope to check you guys later. What I'd really like for you guys to start doing now is to kind of interpret your solutions whenever you find them. That is very important for calculus, because really, as I said, calculus is used in different fields of work. So it will be nice for you to actually start making sense of what is happening, what is the real life meaning of whatever it is that we'll be discussing. All right, I'll catch you guys later. Cheers.